The biofuel that I'm going to be talking about is ethanol. Ethanol is a renewable biofuel made primarily from plant sugars, especially from crops like corn, sugarcane, and barley. It's been used for centuries in different forms, but has gained a lot of attention as a cleaner alternative to gasoline. The increase of biofuels like ethanol is driven by the global need to decrease dependency on fossil fuels, enhance energy security, and minimize the negative environmental effects of burning conventional fuels. Ethanol is primarily derived from crops like corn and sugarcane. Corn is grown in large quantities in the United States, especially in regions like the Midwest where the climate and soil are ideal for this crop. Sugarcane is commonly used in tropical climates, thrives in warm temperatures, and is harvested once it has matured. In both cases, the crops are cultivated using traditional farming methods or more industrialized processes. How is ethanol produced? The process begins with the crops capturing sunlight through photosynthesis. Plants convert solar energy into chemical energy, storing it in the form of sugars in their leaves and stems. The sugars harvested from plants are then processed. For corn, starches are first broken down into sugars, and then yeast is introduced to ferment these sugars into ethanol. During fermentation, yeast cells undergo respiration, consuming sugars and releasing energy to fuel the process. Development status. Ethanol is widely available and is already integrated into gasoline supplies, particularly in the United States, where it is blended into the fuel supply. However, the second-generation ethanol derived from cellulosic biomass is still in development. Researchers are working on making it more economically viable to produce ethanol from non-food sources, which would address concerns about food competition and land use. Ethanol has a reduced carbon footprint compared to gasoline. This is because plants absorb CO2 from the atmosphere during photosynthesis. When ethanol is produced from these plants, the carbon released when the ethanol is burned is roughly equal to the amount of plants absorbed while growing. Life cycle emissions of ethanol are lower, especially when compared to fossil fuels. Ethanol has a significant economic impact, especially in rural areas. It supports jobs, boosts agriculture, and contributes to reducing reliance on foreign oil, improving national energy security. However, the economic viability of ethanol depends on oil prices. Governments and organizations have run advertising campaigns to raise awareness about the environmental benefits of ethanol. There's also a focus on educating the public about the importance of reducing fossil fuel consumption and transitioning to renewable energy sources. However, public perception is mixed, with some concerns about the impact of biofuel production on food prices and land use. My analysis: ethanol is a well-established biofuel with clear environmental and economic benefits. However, its reliance on food crops and land use raises concern, and its contribution to emissions varies depending on the production process and feedstocks. My recommendation is to support the continued development of cellulosic ethanol to reduce competition with food crops and use agricultural waste and non-food sources. Also, to increase research into more efficient production technologies. Step 1 could be to invest in advanced research to scale up cellulosic ethanol production. Step 2, promote large-scale adoption of sustainable farming practices. Step 3, expand the infrastructure to support biofuels. Step 4, fund public education campaigns to raise awareness of the environmental and economic benefits of biofuels. Here are my references. Thank you for listening.